Good day everyone. We are the Group 3 presenter and I am Kenneth A. Bolok Bolok.
Mars Villarreal.
And I'm Cedric Nil P. Velasco.
And I'm Kevin Brian Mabio.
And I'm Danny Kel Ribo.
And I'm Danica Patlis Victor.
I'm Jacob Vergara.
And lastly, I'm Carl Sebastian Serrano.
And we are here to present to you the topic about understanding mechanical, electrical, and plumbing, or what we call MEF Revit software.
Today, I'll discuss the introduction of understanding mechanical, electrical, and plumbing, or simply called MEP Revit software. So, building information modeling, or also called BIM, has revolutionized the architecture, engineering, and construction, or AEC industry by integrating design, analysis, and documentation processes into a unified digital model. Autodesk Revit, particularly its MEP, mechanical, electrical, and plumbing module, plays a key role in this transformation, offering specialized tools tailored for MEP professionals. This software has become essential for designing, simulating, and documenting MEP systems in buildings. In this discussion, we will explore Revit Map's history, its practical application, basic operation, advantages and disadvantages of using this software. By understanding these aspects, we can gain more deeper knowledge, deeper appreciation for why Revit Map is a vital tool in modern construction projects.
Now, let's discuss the history and development of Revit Map. So, Revit Map is one of the most essential tools in mechanical, electrical, and plumbing system. So, Revit Map was first developed in 1997 by Charles River Software with the goal of revolutionizing architectural design through building information modeling, as we called IBIM. So, unlike traditional CAD software, Revit Map introduced a parametric modeling which allowed architects and engineers to create smart and data-driven models. So in 2002, Autodesk acquired Revit as recognizing its potential to streamline the design and construction process. So to address Revit Map, the specific needs of Map professional is Autodesk to introduce Revit Map as a separate module to provide special tools for designing and analyzing managing mechanical, electrical, plumbing system. So it allows engineers to create detailed 3D models with accurate system data. So nag-ensure siya na mga coordination between different building and components. So dito is nami-minimize yung mga errors. So over the years, makalipas na ng taon, Autodesk has continued to enhance Revit Map by adding advanced analytical data tools to improve system performance. So, nag-add din sila ng cloud-based collaboration to ensure seamless coordination amongst teams, and also nag-add din sila ng automation features to make map system design faster and more efficient. So today, Revit Map is a leading software in the architecture, engineering, and construction agency. So it's widely used to its capabilities in real-time collaboration, parametric modeling, and BIM integration. So this feature makes map system design more accurate, efficient, and sustainable. So in summary, Revit Map has transformed maps system design from traditional to manual drafting to an elegant and collaboration process. That's all.
Now we're going to discuss about the application of the Revit MEP. The Revit MEP caters to the needs of the professional involved in designing, analyzing, and documenting mechanical, electrical, and plumbing systems within a BIM framework. I will going to discuss about the key applications. First one is the system design and modeling. The Revit MEP enables user to design and model complex building systems in a 3D environment. This includes mechanical systems, HVAC or heating, ventilation, and air conditioning systems, ductwork, and thermal analysis. Second is the electrical system, which is lighting, power, distribution, and communication system. Lastly is the plumbing system, which is water supplies, drainage, and fire protection. To put it simply, the application of Revit MEP have a advantages or have the most applicable in for mechanical engineers and also for electrical engineers. Especially we're taking the Bachelor of Science in Mechanical Engineering. It's a really good help for those mechanical engineers to build a system for 3D environment, especially in HVAC systems, ductwork, thermal analysis, and plumbing system, which is water supply, drainage, and fire protection. Second is the coordination and collaboration. Revit MEP fosters seamless collaboration among project stakeholders. The software shared models allow architects, engineers, and contractors to work simultaneously, identifying and resolving clashes before construction begins. The coordination and collaboration had great impact for the application of Revit MEP because there's a lot of mechanical engineers or civil engineers and especially architects also can collaborate and fix mistakes before they conduct or build the system or the construction of that building or that machine. Third is the analysis and simulation. The software supports energy and performance analysis, enabling professionals to optimize system efficiency. For example, Revit MEP can simulate thermal loads, airflow, and energy consumption to ensure sustainability and compliance with the green building standards. So, in the analysis and simulation, we can analyze whether it's the machine or the construction will be a green building standards that will not harm the environment itself, especially for the HVAC or heat ventilation air conditioning system, and also with the efficiency when it comes to sustainability of consumption. When it comes to energy or nuclear energy, we can determine that the simulation of the green building standards will not affect any environmental system. Fourth is documentation and detailing. Revit MEP automates the creation of detailed drawings, schedule, and reports. These documents dynamically link to the model, ensuring that the updates to designs are reflected across all documentation. The Revit MEP have the automated creation detailed drawing, so it will help the mechanical engineers or all engineers and architects to have these documents of detailing on what is the project or what will be the project is. 5 is the clash detection. By integrating with tools like Autodesk Navisworks, Revit MEP allows for clash detection between MEP system and other elements, reducing the likelihood of errors during the constructions. This will greatly help the engineers to determine and less the errors during the construction, because there will be no more emergency or life-threatening situation for the people who will construct that system or that building that needed of the Revit MEP will now can create a simulation like the simulation or clash detection before they do that kind of machine. Number 6 is customization and extension. Users can create custom families, templates, and workflows tailored to specific project needs. Additionally, integration with a third-party plugin extends Revit MEP functionality. This is a great function of the Revit MEP because we can plug some of the tools that we need to create a machines. Like for the HVAC, we can plug some more apps that we can help building our machines in the future. Lastly is the life cycle management. Revit MEP is not limited to the design phase. It can be utilized throughout the building life cycle, including construction and facility management. The detailed digital models can serve as a reference for maintenance and renovation and future expansion. It means that the Revit MEP is not just limited to its design phase, but it can also utilize throughout the building. It can utilize what will be the future of that building, what for the renovations, for the expansion of that machine, or for innovation for more expansion. That's all for the application of Revit MEP.
Now, we will move on to the basic operation and processes of Revit MEP. Pag sinabi nating operation and processes, we're talking about how the software works step by step, from the moment we start the project hanggang sa final analysis. Revit MEP is used to design and model mechanical, electrical, and plumbing system in a smart, coordinated, and efficient way. So, let's discuss some steps para mas maintindihan natin kung paano ito ginagamit mga project. The first one is the project setup. The first step is setting up the project. Here, you can either create a new project or use a template that is already designed for MEP system. These setups include defining important project parameters such as the unit of measurement, building levels, and grid lines. These elements create the basic frameworks on which the entire MEP design will be built. It is like laying down the foundation before constructing the actual system. The second is import or link architectural models. After the initial step, the next step is to bring in architectural or structural models in your MEP project. This is done using the Link Revit feature. By linking the models from architecture or structural teams, MEP designers can ensure that their systems are properly aligned and coordinated with the rest of the building. This step is important because it helps avoid conflicts and overlap between MEP and architectural features like wall or beams. The third one is the define MEP systems. With the architectural context in place, it is time to define the MEP system. In this step, you will use Revit system settings to set up mechanical, HVAC, electrical, and plumbing system. You will specify the materials, component types, and sizes such as pipe, ducts, and cable. This definition stage lays the groundwork for what will be installed in the model and how the system will function together. The fourth one is place components. Once the systems are defined, the next step is to place the components. These are the actual physical elements of the system, such as air, handling units, light fixtures, electrical panels, and plumbing fixtures. Revit provides tools to accurately position these components using alignments and snapping features. Properly placement is essential for clarity, accuracy, and smooth coordination with other disciplines. The fifth one is connect system. After placing the components, they must be connected to form working systems. Revit allows you to connect elements using tools for ductwork, piping, and cabling. When the components are properly linked, the software automatically calculates the size and routing based on the system needs. This helps ensure the design is efficient and meets engineering requirements. The sixth is perform analysis. The final step is to analyze and perform of the design system. Revit MEP includes powerful simulation tools to run various analyses such as load, calculation, energy consumption, and airflow distribution. These insights help designers optimize the system before the construction begins. This ensures that the MEP system are not actually functional but also energy efficient and compliant with the industry standard.
Okay, continuation of basic operation and process of Revit MEP. So we have number 7, flash detection and coordinations. This is that use Revit's interference detection tools to identify flashes between MEP systems and other building elements, and resolve conflicts before construction to avoid errors. So at this stage, Revit's interference detection tools are utilized to identify and address clashes between MEP systems and other building components. So these tools are essential to detecting potential conflicts in early design process. By resolving these issues before construction begins, project teams can significantly reduce things like errors, delays, and costly rework. Effective flash detection ensures better coordination across disciplines and contributes to a smoother project execution. Next, we have generate documentation. Create detailed drawing schedules and reports directly from the model. Generate plan sections, elevations, and material takes-off. So once coordination is complete, once this is completed, the next step involves producing comprehensive documentation directly from the model. So this includes the generation of detailed drawings, detailed schedules, and reports necessary for the construction and project management. So Revit allows users to create accurate plans, accurate sections, accurate elevations, and material takes off, ensuring all the stakeholders have access to clear and updated design data. So this documentation serves as a critical reference during the construction phase. We have the next one, number 9. Review and finalize. Review the design for accuracy and compliance with project specifications. Make necessary adjustments and finalize the model. So this step involves a thorough review of the design in terms of accuracy and alignment with the specified project requirements. So any discrepancies or issues identified during this stage are addressed through necessary adjustments. So the model is refined and finalized to ensure it meets all the standards and expectations before being shared with the broader team, the external parties. So the last one, number 10. Export and share. Export the completed model to documentation in formats like WP, PDF, or IFC. Share with stakeholders for further review or implementation. So this is the final step in the MEP workflow. The final step is exporting the completed model and its associated documentation. Common export formats, let's hear that it includes PWG, PDF, and IFC, which support collaboration and interoperability with the other platforms. So the other platforms uses these formats, WP, PDF, and IFC. So the exported files are then distributed to the stakeholders, such as the contractors, consultants, and their clients for further review or for further implementation. So this step ensures that everyone involved has access to the finalized and accurate model for the execution. So that's all for the basic operation and process of Revit MEP.
So this part, we're now at the advantages of Revit MEP. So at this part, we'll explore the key advantages of utilizing Revit MEP software in mechanical, electrical, plumbing, engineering design. So we'll examine how this technology enhances collaboration, accuracy, efficiency, and overall project success. So first is enhanced collaboration. So this elaborates image showcasing multiple users collaborating on a Revit model via BIM 360. So Revit MEP is cloud-based capabilities, particularly through platforms like Autodesk BIM 360, foster seamless collaboration. A centralized model allows all stakeholders, engineers, architects, contractors, and clients to access and contribute in real time. This shared environment significantly reduces miscommunication, ensures everyone works from the same updated information, and streamlines the design review process. So next is improve accuracy and consistency. This visualizes the before and after comparison, showing inconsistent result by parametric modeling. So Revit MEP's parametric modeling is a game changer. It changes made to one component automatically update all related elements, eliminating the consistencies and errors often found in manual drafting, which ensures accuracy throughout the design process from conceptualization and fine documentation. Next is increased efficiency and automation. So this emphasizes the chart comparing manual versus automated task completion times. So automation is key to efficiency. Revit MEP automates tasks such as duct and pipe sizing, system routing, and clash detection. This reduces the time and effort spent on repetitive manual processes, freeing up engineers to focus on higher-level design decisions and problem solving. So the software's intelligent tools significantly accelerates project timelines. Number 4 is advanced visualization and client communication. This visualizes the stunning 3D rendering of a building's MEP system within the architectural model. So Revit MEP's advanced 3D visualization tools provide a clear, comprehensive understanding of MEP systems within the building context. So this allows designers to identify potential issues early, and it greatly improves communication with clients. Clear visualizations lead to better client buy-in and fewer costly revisions later in the process. Next, so number 5 is sustainability and energy efficiency. So it visualizes energy analysis results displayed within the Revit interface. So these built-in energy analysis tools enable engineers to design more sustainable and energy efficient systems. So this Revit MEP allows for the evaluation of different designs options, optimizing performance while minimizing environmental impact. So this aligns with the growing demands for green building practices. So number 6, it's comprehensive documentation and reduced errors. So examples of automatically generated schedules and documentation. Revit MEP automatically generates detailed schedules, material takeoffs, and other essential documentation directly from the model. This eliminates the need for manual data entry, reducing errors and ensuring consistency between the model and documentation. So this streamlined process saves significant time and resources. Number 7 is scalability and project versatility. So this visualizes examples of Revit MEP's project ranging from small residential to large commercial buildings. So Revit MEP handles projects for all sizes, from small residential buildings to large. So complex commercial developments. So its scalability makes it a versatile tool adaptable to diverse project needs. Next is slide 8. Wait, number 8. Proactive risk management. So this visualized example of a clash detection report highlighting potential conflicts. So by identifying potential conflicts and inefficiencies early in the design phase, Revit MEP proactively it mitigates risk. So clash detections tools highlights potential problems before construction begins, avoiding costly rework and project delays. Next is industry standards compliance. It visualizes logos of relevant international building codes and standards. So Revit MEP complies with international building codes and standards, making it a reliable tool for global projects. So this ensures design meet regulatory requirements, reducing potential legal and safety issues. So in conclusion, Revit MEP offers a comprehensive suite of tools that significantly improve the MEP design process. So by enhancing collaboration, accuracy, and efficiency and sustainability, Revit MEP empowers engineers to deliver high quality, cost-effective, and environmentally responsible projects. So it's a very powerful investment in the future for MEP design.
Now I'm going to talk about the disadvantages of Revit MEP. Though it is a great tool for designing building system, it does have some drawbacks. The first is steep learning curve. There's a lot to learn. With so many features, new users can feel overwhelmed and need time to get comfortable. The second is the high cost. The licensing cost can be high, especially for smaller firms or solo users. Plus, you'll need to keep up with hardware and software subscription. The third is this will need to have a strong hardware. To run smoothly, especially on big or complex projects, you'll need a powerful system. Otherwise, expect some logs or crashes. The fourth disadvantage is not always compatible. While it supports several file types, working with non-Autodesk tools isn't always smooth. Sometimes, you'll need extra software just to make things work. The fifth disadvantage is customization isn't easy. You can customize Revit MEP, but it's not easy. It's not simple. Creating custom elements or workflow takes time and technical know-how. Excuse me. The sixth disadvantage is accuracy is the key. If the data going isn't accurate, mistake can carry through the entire project. That means more rework later. The seventh disadvantage is update issue. Frequent updates can cause problems when working with teams using older versions. Compatibility isn't always seamless. The eighth disadvantage is big initial investment. Switching from older CAD tools to Revit means spending on training, new hardware, and adjusting your workflows. It's a big shift, I can say.
So to summarize everything that has been said, Revit MEP has proven its worth for being the foundation of the AEC industry. It has enabled countless professionals and designers to build, analyze, document, and detail systems with unparalleled accuracy and efficiency. This software has offered features that are unmatched in terms of their usage and in the way that it made designing and building systems seems effortlessly. Its collaboration tools contribute to the reason why it is the best choice for complex construction projects. Unfortunately, Revit MEP software is very costly. Not to mention, it requires advanced hardware that can handle the software. Additionally, it has a steep learning curve that requires years of experience and mastery to fully utilize. As modern technology continues to evolve, Revit MEP's power is expected to rise as well. enhancing the capabilities and efficiency of the work, ensuring that the quality is in its highest standards. Revit MEP will continue to be one of the critical tools for the AEC industry, developing as much as it is needed.
And that's the end of our presentation about understanding mechanical, electrical, and plumbing, or what we call MEP Revit software. Thank you everyone for joining and listening to us. Have a great day. Thank you.